This project marks the second time I've worked with the Arduino platform. I spent significantly less time building this than I did my previous one. This time, I didn't have to spend hours researching the path of the current or teaching myself C++. I could simply program and build, which is a lot more fun. This time, I wanted to use a component that I'd previously avoided, the buzzer. While I was building my first circuit with an RGB LED, I read that buzzers are very fragile and easy to short circuit, which having just fried a circuit board didn't make them seem like the product for me. But as I became more and more comfortable with the Arduino platform, I decided to push my boundaries a little. I ended up finding working with a buzzer much easier than working with an RGB LED, and I didn't short circuit anything. For this project, I used an Arduino MKR1000 circuit board. It's one of Arduino's newest circuit boards and simplifies the process of connecting to Wi-Fi networks. The objective of my project was very simple. I wanted to activate a Piezo Capsule, or buzzer, to sound 3 tones every 1,000 milliseconds, or every second. Just like in my previous circuit, my computer acted as the power source, and it connected to my MKR1000 through a USB cord. The buzzer itself sat in the breadboard. The columns under the plus and minus headers are connected, and the rows in the main section of the breadboard labeled with letters and numbers are also connected. This means if I place a buzzer in row 4, and a wire connected to the circuit board in row 4, the buzzer connects to the circuit board. It was using this method that I linked my MKR1000 circuit board to my buzzer. Electrons flow from the circuit board to the buzzer through the circuit board's output pins. Output pins drive voltage and current to the buzzer through individual wires. I connected a wire from the output pin to the breadboard, but instead of connecting the wire in the exact same row as the buzzer, which would automatically link them, I placed it in a completely different location in the main portion of the breadboard. Here's why. In my last project, I accidentally fried my board because I had too much current going through the circuit, but this was a very easy problem to solve. I just had to add resistors. Resistors lower the amount of current traveling through a circuit. As opposed to just connecting the wire from the output pin directly to the row with the buzzer in it, I added a total resistance of 110 ohms by connecting two 220 ohm resistors in parallel, in between to prevent short circuiting. Then I used more wires to connect the buzzer to a space under the ground header on my breadboard to link back to the ground pin on my MKR1000, completing the circuit. As I said before, the objective of this circuit was to activate a buzzer to play 3 tones every 1,000 milliseconds, or every second. My program, which I wrote in C++, tells the buzzer to sound a tone, wait 100 milliseconds, sound a tone, wait another 100 milliseconds, sound a final tone, then delay for 1,000 milliseconds before repeating the pattern. As I said before, I developed this circuit much faster than I did my LED circuit. These projects are becoming more and more basic to me. So, for my third and final circuit in this series, I think I'm going to kick it up a notch.